So here's another example of how to do binomial expansion using Pascal's triangle. So first, let's just go ahead and write out Pascal's triangle, at least as best as we can. So we're going to start with 1 up here, then you have another set of 1s, and then remember we're going to always start with 1s, always end with 1s, and then we're going to add the 2 in the middle here. So 1 plus 1 is 2. So I keep going here. I'm going to start with the 1. I'm going to add these 2 to get 3. I'm going to add these 2 to get 3. And I'm going to have a 1 again. Oops. A 1 again right here. Sorry about that. So we know that this is for a binomial with a term of 0. This is for when there's to the 1 power. This levels to the 2 power. This levels to the 3 power. Okay, so these are the corresponding coefficients. The corresponding coefficients depending on the exponent or the degree that we're trying to expand to. So here we have our problem x plus 2 to the third power, So we're going to be using this row here. So our coefficients we already know are going to be 1, 3, 3, and 1. Okay, 1, 3, 3, and 1. So we can go ahead and actually just write those. 1, 3, 3, and 1. I'm going to leave a lot of space in between there just so that we have room. Alright, so now we have to go ahead and take x plus 2, and we just got to put them in there. Well, we know from binomial expansion that what we're going to see is we're going to start with x first, and that's going to start to the power that we're trying to go to, which is 3, and it's going to go down from there. So we're going to start with x to the third. Next one's going to be x squared. And then we have x1. And we could write x0 here, but x to the 0 is just 1. We know that anything to the 0 power is always just equal to 1. So we don't need to write that, so we'll just leave that alone here. Now we know that our next part is going to be the second piece of our binomial. In this case, it's 2, and that's going to be taken to the powers as well. But instead of going 3, 2, 1, we're going to go, or 3, 2, 1, 0, we're going to go 0, 1, 2, and 3. So 2 to the 0 is 1, so we can just leave that there, but now we have to go 2 to the 1, 2 to the 2, and then finally 2 to the 3. Alright, and these are going to all be added together. We're just going to add all of these together. So we're almost done there. All we now have to do is, well, we got 1x3, so that looks okay, so we'll just do x to the third. Oops. See that one? Okay. So this is going to be x to the third here. And now we have plus, and we have 3x squared 2 to the first. Well, 2 to the first is just 2, so we can multiply 3 and 2 together, right? Because they don't have variables, so we can do 3 times 2, which is 6. And x squared is just going to stay x squared. So we have 6x squared here. And I'm going to do another addition sign. And now I'm over here. So now I have 3x1, 2 to the second. Well, 2 to the second is 4. So 3 times 4 is 12. x1 stays the same. So we have 12x. And then last but not least, we have plus. We got 1 times 2 to the third. Well, 2 to the third is just 2 times 2 times 2. 2 times 2 times 2 is 8. And 1 times 8 is 8. So our last term is just going to be the constant 8. So here we have our expanded polynomial, okay? We started with a binomial, and then we took that to a power and expanded out. We got here. We didn't actually have to do box method or anything. We just used Pascal's triangle, okay? And then we took the first part of that binomial and counted the exponents down, okay, from our starting one, which was 3. And then we took the second part of our binomial and started at 0 with an exponent, and then worked our way up to the one we're going for, which in this case was 3. So what we end up having is x cubed plus 6x squared plus 12x plus 8.